All right, what's happening? I really wanted to take a deeper dive into this kind of summarizing tweet that I made last week. And I'm under the impression that, or I feel that most people they will be more likely to change their habits or to change the way they do things if they really understand why it can be beneficial for them or the mechanisms behind certain things. So definitely going to take a deeper dive with this video. Reducing the amount of mitochondrial stress leads to an increment in health and viability within a cell. Mitochondria are our cell's batteries. They generate most of the chemical energy needed to power the cell's biochemical reactions. Chemical energy produced by the mitochondria is stored in a small molecule called adenosine triphosphate, so ATP. When the cell needs more energy, the mitochondria can reproduce more energy by growing larger and then dividing. So they naturally go through this death and growth process. Fundamentally, though, energy comes from the sun and then finds its way into food, and then the storage process which happens with the breakdown of foods for us to function. Without food stored as fuel, we will die. We cannot use energy directly from food. It must be first converted into adenosine triphosphate, which is the immediate usable form of chemical energy utilized for all cellular function. The body stores a minimal amount of ATP within muscles, but the majority is synthesized from the foods we eat. The nutrients we consume are broken down and then transported through the blood to either to be used in a metabolic pathway or stored for later use. Storage can be in muscle, adipose tissue, or even within organs. We cannot store a significant amount of ATP, but we need a continuous supply. It must be constantly resynthesized. This occurs in several ways using one of three energy systems or pathways. Number one is the phosphogen system. So this is our immediate source. The phosphogen pathway is the first energy source called upon at the beginning of any exercise or in a burst of quick movement, usually things that are too quick for other systems to be called into action for. It uses creatine phosphate to generate ATP. So there's things like jumping, and weightlifting is a good form of this. Next up is anaerobic, somewhat slow, uses carbohydrates. And number three is aerobic, quite slow, uses either carbohydrates or fat. So how can we use this knowledge about mitochondria to help us have more energy in our daily pursuits? So number one is exercise, of course. Exercise generates mitochondrial biogenesis, which is the production of new cells. High intensity exercise, so exercise being at 75% load or more and or 75% exertion or more, activates biogenesis. A single session of high intensity exercise starts this process and elevates cytosolic concentrations of several metabolites in the cells. Cytosolic is a liquid found in the cell. This initiates a cascade of signaling events in numerous pathways, leading to the upregulated expression of genes encoding proteins for this mitochondrial biogenesis, and also fatty acid oxidation. Fatty acids are the building blocks in our bodies, and the oxidation of this is the mitochondrial aerobic process of breaking down that fatty acid. Exercise consistently and you compound this process of rewriting and upregulating gene expression. We also have to consider that not all exercise is made equal, and how you execute movements is very important. Exercise that stimulates bone density adaptations will also optimize this process. You only get this bone density adaptation with heavy weight training or things plus 75% load. How you utilize the bone structure is also important, but that's another rabbit hole we can go down another day. So below I'm going to leave an image, a summary of diseases or conditions that have been linked to suboptimal mitochondrial characteristics. Number two, fasting encourages mitophagy, which is the throwing out of old batteries. Current evidence overwhelmingly suggests that calorie restriction and fasting induces mitophagy. Based on the current evidence, it can be concluded that fasting or calorie restriction has a promising role as a novel and practical way to prevent age-related diseases without any side effects by inducing this mitophagy in the different organs of the body. So, to quote Dr. Jason Fung, a nephrologist, this is basically a kidney specialist, and one of the main functions of the kidneys is to remove waste and toxins from the body, but also to help make hormones, produce red blood cells, and to turn vitamin D into its active form. So to quote him, fasting stimulates autophagy and mitophagy, the process of culling the old dysfunctional mitochondria. So the ancient wellness practice of intermittent fasting essentially gets rid of the old mitochondria and at the same time stimulates new growth. This is the process of renewing our mitochondria, plays a huge role in the prevention of many diseases we currently have no acceptable treatment for. These diseases of excess growth. Okay, the third and final point, actively reducing stress helps to not drain these batteries. Poor management of stress leads to our cells experiencing stress, and cellular stress affects energy levels, mental well-being, sleep, and beyond. Cell stress is when your cells are being negatively impacted by external and internal factors, which compromises their ability to function efficiently. So what is the routine for stress management? There are a number of great ways to increase parasympathetic activity, bringing your body into a state of calm, telling your vagus nerve that there is no need for a fight or flight response. However, the power of sleep is undeniable. A good night's sleep is good for the mind, but also the cells, as through rest our neuroendocrine system recovers, balances, and we'll be able to handle our emotions better the following day. Sleep deprivation affects mitochondrial bioenergetics capacity and optimal sleep. Multiple studies have concluded that lack of sleep and/or abnormal sleep patterns can negatively affect mitochondrial DNA, which could then affect your body's growth and repair process. One study published in the journal Scientific Reports extends this to our mitochondrial's ability to fight cell stress. Cell stress, also known as oxidative stress, is what happens when too many free radicals escape from your mitochondria and attack your cells. According to the study, free radicals are produced while you're awake and eliminated when you sleep. This suggests that a lack of sleep inhibits your body's ability to fight cell stress. As your cells are building blocks of your body, cell stress has a potential to significantly impact your general well-being and energy needs. With intention to sleep optimally, you will feel more energetic. The mind and spirit will have fewer excuses to focus on, and that will allow you to commit and focus on achieving your goals.